Here's our objectives. I can write and solve percent problems, which I think it's kind of similar to what we saw before, writing and solving rates, but percentages are just a little bit different. We're going to look at these in a proportion, which we've seen already, just fractions that are equivalent. But now, since we're dealing with percent is per 100, so one of the fractions has to be out of 100. Now, before we get into that, though, on the assignment, you're going to see problems like this that say you got to use benchmarks to solve these problems. And if they have any of these, like these on the exam, then you have to kind of show that you're using these benchmarks in these ways, okay? So 10% of any value can be found by moving the decimal one place to the left, okay? So that means, let's look at an example here. If you had something like, even something like 45 like this, 10% of 45 is taking that decimal right there and moving it here, and 4.5 is 10% of 45, okay?
Oh, just once. Okay.
Just once, yeah. So for 10%, you move the decimal one place to the left. Now, if it's 1% though, so let's look at an example for this. We'll change the number a little bit. Let's do even like 10.2, like this one. If we wanted to find 1% of something like 10.2, and again, there could be more numbers there, that doesn't matter. But now we're going to move that decimal to the left 2 times. So 1, 2, and 1% of 10.2 would be 0.102. That's 1%, okay? Now, why is this important? Is because if you wanted to do mental math, which, again, on the assignment, I suppose they're going to force you to do it, and maybe on an exam, if they wanted something like, I don't know, let's say 2%. 2% of, yeah, what the heck, we'll just do something, maybe that simple, maybe not. Okay, but 2% of 200, again, 2% is relatable to 1%, so you take that decimal, move it over 2 times to the left, and you'd get 2, really 2.00. But this is 1% of 200, and then 2% is double 1%, so 2% of 200 would be just multiplying that by 2, and 4. I'm putting the decimal there even though we don't really need it. 4 would be 2% of 200, okay? Now again, that's, in my opinion, that takes a little bit more experience, which you will get on the assignment. And once you get some experience with that, you may be like, hey, that's pretty cool. Otherwise, you may be like, you know, that's crap, and I hate it, which is, it's common enough in a math class. So let's say we did the same thing, but now let's say we did 20% of 45, right? So we already did 10% of 45 is 4.5, but so 20%, right? 20% is double 10%. So if we're going to double 10% and it's 4.5, you'd multiply that by 2, and you'd see 20% of 45 is 9. Okay, that's just something you'd put in the calculator, right? 4.5 times 2, and you get 9. Now you know 9 is 20% of 45, okay? Again, is that cool? Is it awesome? I don't know. As a math nerd, we do geek out about this kind of stuff, but not everyone does. So, okay. So, yeah, once you know one of these values, either 10 or 1%, you can even combine them. Once you know them, you can manipulate the values to find other percents without a calculator, which is what they're going to do on the assignment and probably on the exam. Okay, so let's do these, all right? So use benchmark percents to find the following. So 3% of 36, okay? So 3% is pretty close to 1%, or, you know, it's a single digit is kind of what we would say here. So if I wanted 3% of 36, I would look at 1% of 36 first, okay? And then once we know what 1% of 36 is, then we can triple it. So since we're looking at a 1% here, we're going to take 36. I'm going to show it over here on the right, 36. 1%, we would move that 2 times to the left, that decimal, which would be, it's not showing, but it would be right here. That's 1, 2 times to the left, and then would get 0.36. Okay? Now, 36 hundredths really is not a super awesome number to work with. It doesn't mean that your mental math is going to be quick. But now that we have that, though, we can take that, that's 1%, the 0.36, the 36 hundredths. And since we're looking for 3%, 3% is triple 1%. So I can take that 36 hundredths and then just multiply it by 3. And even at this point, I mean, I would still just use a calculator for this one, but, you know, it's up to you. So that's what I got, yep. 1.08. Okay, so again, I'm not saying you have to do this multiplication by hand. I would still put this into a calculator, get 1 800ths, boom, you're done. So 3% of 36 is 1 800ths. So let's do 20% now, okay? Now 20%, they're specifically giving us a 0 there so that we know that it's relatable to 10%. Now, I'm saying that right now because that's going to help us prepare for this one down here. You got 32%. We're not doing it yet, but you may have to combine both strategies if they give you something like this on the assignment, okay? But as of now, 20% of 36 is good enough to know that we have a 0 in the ones place value for the percentage, which means we're looking at some kind of benchmark of 10%. All right, so you see they're using the same number, 36, and they're doing it both times. In any case, though, 20%, it does end with 0. Now, again, we're finding 10%. Once we figure out what 10% is, we can double that, and then we will know what 20% of 36 is. So if we started with 36, like we did before, in R, then 10% moves the decimal 1 place value to the left, which makes this 3.6, 3 6/10. 3 6/10 is 10% of 36, okay? Now, since they're asking for 20%, and we know 3.6% is 10%, we're going to double that, so I'm going to multiply this by 2.
7.2.
There it is, yep. And that will tell us 20% of 36. So I'll just write this in is 7 2/10. Now, are there other ways to do this? Of course there are. But again, this is just using what they say is benchmark stuff, okay? So we are using 36 here. And just like we see up at the top, we know, in fact, let's start with the 10%. So I got 32% would be 30%. And then they would say add another 2%, right? So we're looking at both the 10% figure and then also the 2% figure. Okay, so if I wanted, which I do, 10% of 36, which we have at the top, just the 10%, right? I'm not looking at 30% or even the 20%, but I remember down over here, 10% was the 3.6. So that was 3.6. That came from just moving the decimal 1 time to the left from where it was, okay? And then the 2%, that's going to help us with the 1% benchmark. And 1% of 36 is, we found that up there at the top, 0 36 hundredths, which is here. So that was moving the decimal 2 times to the left, okay? So 10% of 36 is 3.6. What we want right now is 30%, right? That's the 3 portion of the percentage. So I would take 3.6, multiply that by 3, and whatever I get out of this is going to be 30% of 36. So 3.6 times 3, enter, and I get 10.8. All right, now 1% of 36 is 36 hundredths, but we need 2%. Okay, so we're going to take that 1% and then double it. So we're going to multiply this by 2, which should be 72 hundredths, like this one. And now with these two values, we're going to take them both and we're going to add them together, okay? Because once again, 10.8 is 30% of 36, and 72 hundredths is 2%, which again, when we combine these percentages, you would get 32%. So when I do this, we get 11 and 52 hundredths is 32% of 36. Boom. But this is the one we're looking for. All right, when solving a percent proportion, you can also use an equation. I stick with the proportion, but I'm going to show both the proportion and the equation. That may be redundant because they're both equal signs in the formula on these. But one thing you're going to want to notice on these, I like the percent proportion because I don't have to change anything. All right, in the percent equation, you have to be able to change that percent into a decimal. Unless you're going to use the percent sign on the calculator, which you can do. But a whole times a percent is going to be the part, okay? That's the equation. But the percent proportion, you're going to take the percent over 100. Again, it's percent per 100, which is showing right here, percent. Now, we're not changing that number, though. Whatever percent they give us is just the number that goes here. We don't care about the sign anymore because it's over 100, which is kind of the sign. In these problems, you're kind of looking for these two words, is and of. But when we look at word problems later, what's going to happen is it'll be important for you to understand that of the two values that they may give you or ask for, the part is not all of whatever it is they're asking for, okay? The whole is always like a total or everything or something like that, okay? And then part, for example, I'll give you this example because we probably will see something like this. So you can have all of the tickets that may have been sold into an amusement park. That would be the whole, all of the tickets. Part of the tickets may be like adult tickets. And then another part would be like children's tickets or something like that, okay? So if you know what you're looking for, then you can plug those in. If you're going to use the equation, which again, I'm going to be doing these on these examples, the same idea goes for the whole and the part, but you have to know which is which in order to enter them into the equation. If the whole or the percent is missing, you'll need a principle of equality to solve. If you know how to plug these in to the percent proportion, it's straight fish method because that's what we liked, right? So that's all I'm going to be using today is fish method when we see these percent proportions. But again, if you want to use any of the other methods, you can. So again, I'm going to set this up two different ways, and you get to decide which one you like the most. I think the equation right here comes with, it should just happen with more experience. Once you're like, you know what, I understand what this is doing, then you'll be like, I don't really necessarily need this. But until then, let's start with the percent proportion, okay? So let's start by setting up our percent proportion, okay? So you got two fraction lines that are equal like this. But again, one thing that will always be consistent in these percent proportions is that you will have 100 on one of the denominators. The percent will always go above 100. Now, I like it on the left. Some students like it on the right. It doesn't matter. Okay, but what I see here, let's go to the problem now. Let's read it. I have it set up. Now let's read it. What is 280% of 74? Here it gave me a percent, 280%, okay? Well, I see that the percent goes above 100. Now again, I don't have to move the decimal here. I just plug it in, 280, boom, that's it. Okay, it is 280% of 74. Of, okay, remember of is the whole. So right there, of 74 has to be the denominator. Now again, you could think, well, why is 74 the denominator? Because that's all of it, of whatever this is. 74 is all of whatever this is. Units, I guess, okay? The thing that we don't know is how much that is of 74. Okay, so once again, I would say let's take this, and it's a proportion, but this is a percent proportion. So we're going to use fish method to solve this. Multiply, divide, and equals. Yep, so we always go up and down to start the tail of the fish. So that's an x that goes down to 74. You can always start at the x, which is where we're going to end as well. The first number I encounter is 74. I cross up to make the body of the fish. Then I got the 280. Then I'll swing back down to make the head, 100. And then I finish off where I start, and that's an x. Now I can plug this into the calculator directly, and that will tell me what 280% of 74 is. So here we go. Okay, and this is what I got. I got 207 and 2/10. Now I don't need to show that that's equal to x. I can just box this in because I put the x here. So whatever variable you want to use is fine. I used an x. I just don't need to show that it equals x because I put that in there, okay? Now that is the percent proportion method, which since we're used to seeing fish method, hopefully that wasn't too bad. The percent proportion, again, it takes a little bit more work, but it's doable. So we're gonna look at, see right here's our percent. Well, what is the percent? We need this as a decimal. So you take 280, you can either divide by 100 or you can move the decimal 2 times to the left and you'd get 2.8. Now again, you have to know which is part and which is whole. Just because I see the word of right there means I know that I'm dealing with the whole right there. And in my calculator, I can type 74 times 2.8 and that will tell me the part, which will again give you 207 and 2/10. So you'll get the same exact answer either way. This one did not require any principles of equality to solve, which is when it gets kind of nasty, but it's still doable, okay? You'll get the same answer both methods. Okay, try this one out. Now this one's worded different, so you gotta be careful, but what percent of 36 is 648? Try this one out. All right, now the first thing on this one, right, so I've got my percent proportion set up. And they say, what percent? That means we don't know the percent. And so for me, I'm gonna use an x where the percent goes, which is always above 100, always, okay? Next up, I see the word of, which is an important word because the of tells me the whole.
The 36 was on the bottom.
Yep, so we're gonna put the 36 on the bottom, right here. And then it says is, again, which is one of the 2 important words other than percent, I guess, is 648. So we get 648 on the top. Now, it's common to use percentages that are only double or single digits. But we'll see on this one that it's okay mathematically for us to see values that are more than 100%, okay, like this one is, because 648 is much bigger than 36. Well, this sets up a proportion, which we always solve the same way with a fish method, like this. Multiply, divide, then equals. So I make a fishtail with the x down to 100. So that's the first number I encounter. It's the first number on the list. And then I cross up to make the body. That's 648. Then the head down to 36. And then I finish always where I start at the x or whatever the variable you're using, okay? So this fish, unlike the last one, is now facing to the right because the x was on the left side of the equal sign, okay? But I put this into the calculator, and this will tell me how much of a percent 648 is of 36. And when I did it, I got 1,800. Now, this is where things get a little tricky because you get 1,800 on the calculator, but it was asking specifically for the percent, what percent? So make sure that you label it. When it asks for a percent, make sure to label it as a percent. Otherwise, on an exam, you can lose out on points, which we don't want. The main words we're looking for here are percent, of, and is in these types of questions, okay? Now again, if you know that it's part over whole, because the part tells you how many of these whole size pieces there are, then you don't really need the is and of it. It can kind of make sense. I don't think I do a good job of explaining because I'm a math nerd, but maybe some English nerd could tell you better than I can, but that's the way that I look at it. In the percent equation here on the right, The percent is the value that we don't know. So I would replace that with an X. Now again, what I get out of this one is going to be the decimal value, not the actual percent. So I'm gonna have to convert that back. The whole, again, it's the of, or all of it, which is 36. And that's gonna be multiplied by X. This is gonna equal the part, which is the is value, which is 648. This is just an equation that you need to solve. And in order to solve it, we'll divide both sides by 36. Which again, the problem with this, or one of the problems we encounter is that students look at this and they're just like, oh, it's 18%. No. Remember, this is the decimal value, not the percent. So then you'd have to move the decimal, right? Would make this 18 point. You'd have to move the decimal 2 times to the right, or multiply it by 100, whichever one you prefer. And then you would get 1,800%, just like we did with the percent proportion, okay? And this is another reason why I prefer the percent proportion, because it will give me the percentage right away. I don't have to move any decimals in any of the cases. But with the percent equation, you will have to move the decimal. I guess you could like make just like 100 times this, but it'd be divide. This is just the way it comes out, I guess. Whatever. Okay, now we got a fraction here, all right? So 80% of 2/5 is what number? And once again, don't forget, when you're using this percent proportion, start with your 2 fraction lines that are equal, because they always will be, and then plug in your 100 here on the bottom left, then plug in the rest of the values. But try this one out. Try this one out, then we'll go over it. In this percent proportion, let's go ahead and set this up. They did give us a percent, right? Now this one, they're actually showing the percent symbol. The couple problems ago, they just said percent, and you have to be aware of that as well. But the 80%, I can just plug in directly above the 100. Boom. I know where that goes. The next value says 2/5, but it says of, right? So of is going to be the denominator. So the 2/5, even though that's a fraction, it shouldn't be a problem. Hopefully it's not a problem for us. We can just plug that in. What we're looking for is the part on this one. It did say also is what number, which tells us we don't know what that value is, which is why I'm using an X. Okay, so this is the percent proportion that we're going to solve with fish method. So we got the 4 values, which we're going to plug in, multiply, divide, and equals. So I'm going to make the fish. I'll start with the X. I'll go down to the 2/5. So that's my first value, 2/5 times. We'll cross up to the 80. Swing it back down to 100. We'll divide by that, and then we will end at X. And this will tell us what 80% of 2/5 is. And when I put this in the calculator, I got 32 hundredths. So, yeah, if your calculator gave you the fraction, 8/25, it's the same thing. Yeah. So we'll put that in there with it. That is with the percent proportion, which is something we're familiar with, and it's what I suggest you do until you get a little bit more used to this, and then perhaps you would want to use the percent equation. Now, we know the whole here because it said of, and that was 2/5. And then the 80%, again, the percent we need as a decimal, so we'd look at 80%, would have to move that decimal 2 times to the left, which would be 0.80. And again, in the percent proportion, the nice thing is you can just multiply this directly sometimes. But again, you will get the same answer here that I got with the percent proportion, 0 and 32 hundredths. Same answer, just again, shown in a slightly different way. The main thing with these percent proportions is placement of the numbers. After that, it's all about the fish method, which we seem to like decently. And then you can get your answer pretty quick. But you have to know where these numbers go, because if you were to put the 2/5 as the numerator, you're going to get something different. It's going to throw you way off on that one. So the setup on the percent proportion is pretty crucial. Okay, so you drove 16 miles to work every day. You want to determine how many miles you have traveled when you have driven 25% of the trip. I know, and I highly doubt that anyone has ever driven and been like, I wonder where 25% of my trip is. Welcome to math class, right? So here we are. Let's we can do it though, okay? So it says, step 1, plot 25% on the first number line below to represent the percent of the trip you have traveled. So these are percentages. This is a percent number line, which is also lined up so that we can tell how far 25% is down here. You're going to see this on the assignment this way. So all we've got to do on this percent number line is find 25%. Boom, I found it. I put a dot there. Then I get credit for that number line. That's it, okay? What I'm going to do, though, is I'm going to take that and I'm going to follow it down. So let's see if we can. I'm going to follow this down to the next number line down here. And whatever that is going to be 25% of the 16 miles, which is here. Yep, that's 4 miles right there, okay? Now, I should have read step 2, but it says, then plot the corresponding miles of the trip you have traveled on the second number line. That's it. And again, these are going to be lined up this way. You can see that the mileage goes all the way over here to the right in the 16 miles, which it said that's exactly how far your trip is, okay? So these are going to line up very nicely. You shouldn't see any decimals on these just because we're just trying to make a point. 4 miles in this case. Oh, my 4 right there. My 4 miles. 4 miles is the same as 25% of a 16-mile trip. However you want to word that. There's lots of different ways to do it. This is how they want it on the assignment with these number lines. All right, this one says you drove 237 miles of a 269-mile trip. What ratio of the total trip did you drive? What percent of the total trip? That says drip, but it should say trip. Did you drive? What percent of the total trip does you have left to drive? I don't know what happened here with my typing, but we can look past it, hopefully. Okay, so the ratio of the total trip, right? Ratio. Now, there are several different ratios here, but we want a part to whole ratio. We want a part to whole ratio, which is going to help us to set up a percent proportion, right? Now, for me, it's easier to look for the whole trip. And it says that the whole trip is going to be 269 miles. They did use the word of here as well, but you may not have noticed that, and that's okay. Because in this context, we can tell what the whole trip was. It's 269 miles. Okay, what is part of the trip? Well, the part of the trip that we've driven is the 237 miles. So we'll put that in there, 237 miles to 269-mile ratio. Now, I have this written as a fraction. Let's see if this can be simplified. I'm just going to plug it in my calculator with the N over D button. So 237 over 269. Enter. Whoa, that was I mistyped that one too. Yeah, it didn't simplify at all. So this is the only ratio that you can use because it's non-simplifiable anyways. So no problem, okay? The next part, what percent of the total trip did you drive? So we're going to set up the percent proportion, right? Now so we're going to have two fractions that are equal right here. But we already know that one of the fractions is going to be the part to whole ratio. And so we're looking for something over 100, which is always going to be the percent. The percent is what we don't know on this one, okay? So the ratio of the total trip that you drive is going to help us with this percent proportion. Now we're ready to solve this with fish method. So 1, 2, 3, 4, multiply, divide, and then equals. So we'll make the fishtail down to 100. Cross this back up to 237. Swing it back down to 269. And that will tell us what the missing value is, which in this case is a percent. It is a percent, so we're going to make sure that we label this as well. And I got, well, it's kind of an ugly decimal right here, but we get 88. I'll show what the calculator shows me. 88.1040892. You may have seen more decimals than that, which I'm going to round to the nearest tenth. We'll make that 88.1%. They didn't say to round, but I did anyways, because that's an ugly decimal. So So yeah, I have 88 and 0.1%, which means that if you've driven 237 miles of a 269 mile trip, you have now driven 88.1% of your trip. And next time you're on a drive for 269 miles, you'll be like, oh, when we do 237, I'll be at it. And anyways. Okay, so what percent of the total trip do you have left to drive? Well, what you'd like to do, we assume, is to drive 100% of the trip. You've just driven 88.1% of the trip. So if we take these and subtract those, if we subtract 88.1% from 100%, that will tell us how much more needs to be driven, which should be 11.9%. And you just put that in the calculator and get that 11.9%. But now we have all three answers. 1, 2, 3. The store surveyed their customers to find out their ages. The bar graph shows the number of customers in each age group. What percent of the customers surveyed were 35 to 50 years old? Round your answer to 1 decimal place. Okay, so we're looking for the nearest tenth on this one, just like we did on that last one. Here is our bar graph. It should be a histogram, but whatever. Okay, so 15 people were surveyed that are under age 17. 25 surveyed were 18 to 24. 30 were 25 to 34. 15 were surveyed at 35 to 50. This is the one we're targeting, right? Because it says right here. And then 10 were surveyed over 50. So in our percent proportion, which we are going to set up, okay, we're looking for something out of 100. They want to know what percent. So we don't know the percent here. So we're going to put that X over 100 right now. That's where the percent will go. You got part of the group and then you got the whole group, right? So remember, the part always goes in the numerator and then the whole goes into the denominator. Now this one, it's not directly telling us with is and of directly. In fact, you can kind of get this confused and say of is 35 to 50 years old. No, that's not the whole. We need the whole, which is going to combine all of these numbers. So 15 people from under 17, 25, 18 to 34, 30, 25 to 34, 15, 35 to 50, and then 10 here at the end. Let's see, if we add these, it's 40, 70, 80, 95. Okay, so when we add all these numbers together, all these people of different ages together, that means they surveyed a total of 95 people. So that's going to be my denominator there. That's the whole survey. The whole survey is 95 people, but the part that we're looking for is 35 to 50-year-old, which is 15 total people right there. Okay, so we now have a percent proportion, which we are ready to solve for a percent. So we're going to set this up 1, 2, 3, 4, multiply, divide, and then equals. Fix that up a little bit. Okay, so from the X, we'll go down to 100. So that's the first number in. Cross up to 15, second number in. Swing it back down to 95 to then make the head of the fish. And we always end where we start at X. So now that we have this, we can plug this into the calculator. 100 times 15 divided by 95. Enter. And this is the percent. Oh, again, it's pretty ugly. 15.789. 7368. Yeah, so we only want 1 decimal place. Very good. So that's what we will do. The 7 is 1 decimal place. To the right is 5 or more, so we're going to have to add 1 to the 7. And we end up with 15 and 8/10. But this is a actual percent, right? So we'll make sure we label that as a percent for full credit. And so the number of people or customers that were surveyed between the ages 35 and 50 represents 15.8%. That means also another 15.8% rounded to the 1 decimal place were surveyed under 17 as well. That's good. That's good. You are buying a townhouse for $126,000. You are making a 5% down payment. Find the amount of the down payment on this one. Try this one out. See if you can do it, and we'll go over it. All right, so let's see how this sets up. So once again, I'm just gonna do the percent proportion here. Okay, it's always gonna be out of 100, so the two fraction lines that are equal, but 100 is always part of this. Now, we do have the 5% here, so the percent always goes above 100. 5 over 100 is the same as 5%, 5 per 100. Now, we know the townhouse is $126,000. That's the whole cost of the townhouse. Now, you could say, well, yeah, but, you know, you got a commission and stuff like that. No, we don't worry about that stuff. It's 5%, the 5% down payment is on that price. So the whole price is $126,000.
I got 6.
So for this one, what we don't know is the part of the 126,000, which is the down payment. So that's where our X goes. And now we'll use fish method. So 1, 2, 3, 4 values, multiply, divide, and then equals. So we go from X down to $126,000. Cross back up to the 5. Swing it back down to 100. And we always end where we start at X. So we just plug this into the calculator, which I've already done. And I got 6,300. Now again, this is a word problem, right? So it wants to know the final amount of the down payment. This one is in dollars.
Okay, so wherever it goes.
If you're estimating how much you save if you get 40% off the original price of $39.99, calculate how much you save. So the amount that you save is the same as the percent off. So when we set up our percent proportion, okay, so it's always out of 100. They did give us the percent off, so that's 40% off, which again tells you how much you save. I mean, there's some marketing garbage going on there because, you know, if you weren't going to buy it, then you don't save it. You end up spending more and you don't save. Anyways, that's a whole different story. But it says the original price of $39.99. Now, that would have been the whole price. Okay. In addition to that, they did use the word of, but I wouldn't necessarily point that out here, okay? Because what we need to understand is that the $39.99 is the whole price. Okay? So the 40% is based on the $39.99, which again means that it must be the denominator. What we want to know is the part of the $39.99, which is how much we save. So with this set up, now we're ready for the percent proportion to be solved with fish method. So from X, we would go down to $39.99, cross up to 40, swing that down to 100, and then we end where we start always, which should be where the variable is. So yeah, when I put this in the calculator, we get 15.996, but we are dealing with dollars up here. So we'll round this to the nearest penny, which is the 9. To the right is a 6. Add 1 there. 9 plus 1 is 10. Carry the 1. 1 plus 9 is 10 again. Carry that 1. 1 plus 5 is 6. Drop the 1. So $16? That's correct. Yep. The savings with 40% off of this price. I mean, we didn't have to round it, but $16 is good. That's it. I can write and solve percent problems, which we did. We did a lot of them. So get to work on that assignment and get it done.